Have you ever wondered how an app like Instagram can possibly handle a billion users without just completely crashing? Well, the secret is this really powerful technique called Database Sharding. And today, we're going to break down exactly how it works. I mean, just try to wrap your head around a platform like Instagram. We're not just talking about storing over a billion user profiles. It's a constant, never-ending flood of photos, messages, likes, comments, all happening at the exact same time. So how on earth do they handle that sheer volume of data? And really, that's the fundamental challenge that every single growing application eventually faces. How do you manage this absolute mountain of data without everything just slowing down to a painful crawl? Right. This is what we call the billion user problem. It's that critical moment, that tipping point, where you finally realize one single database, it just can't handle the load anymore. So, at its core, the problem is pretty straightforward. Any single server, I don't care how powerful it is eventually gonna hit a wall. Sure, you can try scaling up. That just means buying a bigger, faster, more expensive machine. But that gets crazy expensive really fast. And in the meantime, performance tanks, your users get frustrated, and your app, well, it starts to fail. Okay, so what's the solution? Well, if you can't keep building up forever, you've got to start building out. And that brings us to this brilliant divide and conquer strategy that takes this overwhelming challenge and makes it, a whole lot more manageable. And this solution, it's called Database Sharding. It's what's known as horizontal scaling. So instead of having one gigantic, super expensive server, you spread all the data and the workload across a whole bunch of smaller, cheaper commodity servers. You're literally breaking up one massive database into these smaller, independent pieces called shards. And look, this is not some niche, obscure concept. The tech giants you use every single day, Instagram, Amazon, Google, they all rely on sharding. It's like the invisible architecture that lets them operate at a global scale. In a lot of ways, it really is the hidden backbone of the modern internet. Okay, so we get what sharding is, but that raises a big question, right? How does the system actually know where to find a specific piece of data once you've split it all up? Let's get into the nuts and bolts of how this actually works. So there are three core components that have to work in perfect sync here. First up, every single piece of data gets a sharding key. Just think of it like a unique address, like a user ID. Then that key is used for partitioning, which is basically the set of rules that decides which shard that piece of data belongs to. And finally, you have a query router, which acts like a master traffic cop. It sees the key on an incoming request and just instantly directs it to the correct server. Pretty clever. Now, how you decide to partition that data, that is an absolutely critical choice. For instance, you could use what's called hash-based sharding. That's great for spreading the data out perfectly evenly, which helps prevent any one server from getting overloaded. Or say you have a global app. Geo-Based Sharding is fantastic for that. It keeps European user data on European servers, which makes access way, way faster for those users. The point is, each strategy has its own purpose, and the right choice completely depends on what your application needs to do. All right, so sharding sounds amazing, right? And it is incredibly powerful. But like with any advanced technique, it's definitely not a free lunch. So let's talk about the trade-offs, the balance between all this power and the complexity that comes with it. And this really is the essential trade-off. Think of it like a balancing act. On one side, you get this amazing performance, basically infinite scalability, and really high availability. But on the other side of that scale, you're adding a ton of complexity. Things that used to be simple are now harder, and you're introducing new ways things can go wrong, like how do you make sure your data is consistent across all these different machines? Okay, so knowing all that complexity, how do you actually get it right? Let's walk through some of the most important best practices to make sure your sharding implementation is a success. Success with sharding really just comes down to disciplined engineering. For example, choosing the right sharding key. That is probably the single most critical decision you will make. Why? Because a bad key can create what are called hotspots, where one poor shard gets slammed with all the traffic. And that's exactly why you have to constantly monitor and rebalance your shards to keep that load distributed evenly. Really, it all boils down to planning for that future growth from day one, not waiting until you're already in the middle of a crisis. And this quote from our source material really just nails the main takeaway here. Sharding is a powerful tool for scaling, for sure, but it's not the only tool in the toolbox. You have to be absolutely certain that the massive performance benefits you're going to get are worth all the operational complexity you're signing up for. Which brings us to our final question, one for you to think about. For your next big idea, Is sharding the key that's going to unlock massive scale? Or is it a layer of complexity that you're just not ready for yet? Because getting that answer right, well, that can be the difference between spectacular growth and a system that just collapses under its own weight.